Hello, welcome to Lesson 12, Part 2, Poisson Distribution Examples. In this video, we're going to be doing some numerical examples. All right, first one up. Call centers use the Poisson distribution to model the number of expected calls per hour that they'll receive so they know how many call center reps to keep on staff. Suppose a given call center receives calls at a rate of 10 calls per hour. Find the probability a call center receives 6 calls in the next hour. So the lambda is the 10 calls per hour. Lambda is going to be 10. And x is going to be 6, exactly 6 calls. So plugging into the formula, the probability of exactly 6 calls in a 1 hour period is e to the minus 10 times 10 to the 6th over 6 factorial. That comes out to about 0.063. When you're plugging this into the calculator, make sure you have this negative 10 in the exponent of e. So it's about 6.3% chance of exactly 6 calls in the next hour. All right, second example up. Suppose a typist makes approximately 5 errors for every 1,000 words typed. Find the probability the typist makes exactly 2 errors in the next 250 words. Find the probability of at least 1 error in the next 250 words. So what's happening here is that we're dealing with two different word amounts here. The original rate is 5 for every 1,000, but then they're asking for the probability of making exactly 2 errors in the next 250. So we have to use a proportion, scale that down to match the context of the question. We have a rate here per 1,000 words typed, but the question is working on a basis of 250. So we have to use a proportion or some other conversion here. We need the number of words here to match. So 5 errors every 1,000 words. We're going to convert that to errors every 250. And so you can cross multiply here to solve this proportion out, or you could just also divide by 4 here because it is a 4-to-1 ratio. So you can cross multiply 250 times 5 over 1,000, you get 1.25. So scaling 5 errors every 1,000 words is equivalent to a lambda of 1.25 errors every 250 words. So you have to do that adjustment first. You have to make sure we're working on the same total here. So 250 words. So lambda is 1.25, and then the first part up is to find the probability of exactly 2 errors in that window of 250 words. So we plug into the formula. So lambda is 125 and x is 2. So it's e to the minus 1.25 times 1.25 squared divided by 2 factorial. This comes out to 0.224. Now, the second part was finding the probability of at least 1 error. Now, at least 1 error, that's a lot to count. At least 1 means 1 or higher. 1, 2, 3, 4, and so on. So what you do is you count the opposite. The opposite of at least 1 would be lower than 1, which is only 0. Only 0. So we're going to do the opposite. We're going to count the probability of 0 and then do a subtraction. So it's 1 minus the probability that x is exactly 0. No errors. So what's the probability of 0 errors? It's e to the minus lambda to the x over x factorial. And x is 0. 0 factorial is 1. 0 factorial is 1. So this is defined here. And then again, we're doing the opposite situation. We find the probability of none and then do 100% 1 whole minus that to find the probability of greater than or equal to 1 error. So 0 factorial is 1. We get 1 minus e to the negative 1.25, which comes out to be about 0.7135. So about a 71% chance of at least 1 error in 250 words. All right, number 3, text message users receive or send a mean of 41.5 text messages per day. So our lambda is 41.5 messages either received or sent per day. How many text messages does a text message user receive or send per hour? So again, we have to do the conversion here. The rate here is given per day, but the question then wants this in terms of per hour. So you have to line up those units of time. 24 hours in a day, so we can use a proportion here or just divide by 24. So 41.5 per day is 41.5 every 24 hours, which is equivalent to, dividing by 24, it's 1.7292 per hour. So now we have the time interval lined up. How many text messages does the person send or receive per hour? It's 1.7292. So that takes care of part A. Now, part B is what's the probability that they send or receive 2 messages per hour? I should change the wording here slightly. What's the probability that a text message user receives or sends 2 messages? Let's modify that slightly here. I think it's okay like that, but I think it's a little bit clearer to word the question is, what's the probability that a text message user receives or sends 2 messages in the next hour? Okay. So we want the probability that x equals 2. So it's e to the minus lambda times lambda to the x over x factorial. It's e to the minus 1.7292 times 1.7292 squared over 2 factorial. 2 factorial is 2, and this comes out to 0.2653, which is about 26.5%. All right, this concludes lesson 12. If you have any questions, please don't hesitate to contact me with an email. Thank you.